Okay, so I'm going to try and get a review together for the test on Friday over Trig and graphing. So let's take a look and see what we can do. I'm going to start at the beginning of the document, of course. So what I'm looking at is the very first one. So I went to my calculator and I punched in the sine of 30, and when I did that, it told me that the sine of 30 was a half, so that was pretty straightforward. Let's see if we can get this pen to work. Okay, so I circled that right there. Then it wanted to know what is the sine of 55, or cosine of 55, so I hit the cos button and I pushed 5, and it told me that it was 0.5736. So if you know the angle, then you're just going to hit the button for sine, cosine, or tangent. If you, however, know the sine, cosine, or tangent, and you want the angle, then you need to use sine to the -1 button, or cosine to the -1, or tangent to the -1. Those are also called the inverse sine, the inverse cosine, and inverse tangent. Okay, so if a 15-foot ladder, so the ladder is 15 feet long, is leaned up against a building, so there's my building, not a very good looking building, but there's my building, and from the bottom over to the building, or from the edge of the ladder over to the building is 10 feet, they want to know what is that angle with the ground. So that looks like a cosine to me because I know the adjacent and the hypotenuse, so I'm going to say the cosine of theta is equal to the adjacent 10 feet over 15 feet. So when I divide that, I get 0.67. So I'm right here. I know the sine, or I know the cosine. So now I'm going to do second function cosine, I'm going to say second function cosine, and then I'm going to type in 0.67. And when I do that, I get the angle. And when I did it, I got the angle to be 48.2 degrees. All right. So let's move on to this next little rascal. Roll on down. I believe we're looking at this tree that falls down and breaks. So when it falls down and breaks, we know this is a 50-foot tree. Hypotenuse is 50 feet. We know that this is a 10-foot high. Okay. And they're asking us to find this angle right there. So the sine of theta is equal to 10 feet over 50 feet. And notice I'm putting labels because I want those feet to cancel out. So I know that the sine of theta, when I divide 10 by 50, it's 0.2. So I use second function sine and I type in 0.2. And when I did that, I got the angle to be 11.54 degrees. How far from the stump is the top of the tree? So I'm going to say that they're asking me to find this distance right here. So I'm going to say that the cosine of 11.54 degrees is equal to x over 50 feet. Notice every number is getting a unit, and x, when I do that, is going to wind up being 48.98 feet. Okay. Johnny has a 6-foot piece of plywood that he's going to use to make a bicycle ramp, so there's my ramp. He's going to stack it on top of some bricks that are, or blocks that are 2 feet tall, and they want to know what is this angle right here. So I'm going to say the sine of theta is equal to 2 feet over 6 feet, and that's 0.33 forever. So I'm going to say second function sine, and then I'm going to type in 0.33, and when I do, I get my angle theta to be 19.5 degrees. Alright, John wants to measure the height of a tree, so let's scroll on down and get our Word document where we can see more of it. There we go. Okay, so he wants to measure the height of the tree. We did this with the flagpole, 100 feet out, and he looks up at the top of the tree. It's a Dr. Seuss tree, kind of pitiful looking, and he knows that angle is 33 degrees. We want to know this side right here. So I'm going to say the tangent of 33 degrees is equal to h over 100 feet. So when I multiply the tangent of 33 times 100 feet, I got h to be 65 feet. Okay, now we're ready to go on down here and look at the actual triangles and play with them and see what we can do about that. See if we can figure those out, and I have complete confidence that we can. Alright, so it says find the missing unknown angle to the nearest degree and the length of the missing side. So I said, well, I know two sides, so I'm going to do Pythagorean theorem. So y is going to be equal to the square root of 10 squared. And it's in meters, so I need to make sure that I note that. So 10 meters squared plus 10 meters squared. So when I did that, y was equal to, if I had the answers here, y was equal to, oh wow, this is not what I did. I'm going to have to stop for a minute and get this done. Okay, so I got the calculator and I did the math, and I got 14.1 meters. Then they wanted me to get that angle. Well, I know I have a 10 and a 10, so theta has to be 45 degrees. But I want to show that, so I'm going to say that the tangent of theta is equal to 10 meters, opposite over adjacent. So that gives me a tangent of 1, and a 45 degree angle has a tangent of 1. Okay, this one over here is a 3, 4, 5 triangle. If you don't believe me, say x squared is equal to 4 meters squared plus 3 meters squared. And when you do that, you get x is 5. So there's my 5 meters there. Now I need to find this theta, so I'm going to say that the tangent of theta is equal to side opposite 3 meters over adjacent 4 meters. Those will go out. And so if I do that correctly, I think it's going to be 36.8 degrees, but let's do it real quick. So I'm going to punch in 3 divided by 4. And then I'm going to say, okay, that's the tangent. So I'm going to tangent minus 1 of 0.75. And that gives me 36.9 degrees, just like I thought. All right. So let's move on to the next one. I'm going to scroll down. All right, so let's see. So this one here is 5, and 5 square roots of 3. So I'm going to say c squared is equal to the square, or is equal to a squared plus b squared. So that's going to be 5 meters squared plus 5 square roots of 3 meters squared. Okay, this is 75 meters squared when I punched it in the calculator. This is 25 meters squared. So c squared is going to be 100. So c is going to equal 10 meters. And then I want to say, well, the tangent of theta is equal to 5 times the square root of 3 meters over 5 meters. My meters will cancel. So I said tangent negative 1 of that value gives me theta, and theta was 19.1 degrees when I got through with it. So it would be 19 degrees. 19 degrees. Okay, here I have a 15 and a 10, so I'm looking for b. b is going to be the square root of 10 meters squared plus 15 meters squared. And so that's 100 plus 100 plus 225 is 325, so I get the square root of 325. And when I did that, I got 18 for side B, and that would be 18 meters. And then I want to find the angle, so I'm going to say the tangent of theta is equal to the side opposite 15 meters over the adjacent 10 meters. Those will cancel. 15 divided by 10 is 1.5, so I get my calculator and I go tan -1 of 1.5, and my calculator tells me that that's 56.3 degrees. Alright, down here I have a 5, a 4, this has to be 3. You can do it with Pythagorean theorem and see it's a 3, 4, 5 triangle. And I'm going to say that the cosine of theta is equal to 4 centimeters over 5 centimeters. So that's 0.8. And if I take the cosine, if I look for the angle that has a cosine of 0.8, I'm going to say cosine to the -1 of 0.8. And that's going to give me 36.9 degrees again. So theta is going to equal 36.9 degrees, which if they want me to the nearest degree, I'm going to call it 37. And then this side is 3 centimeters. Alright, and so we're going to scroll down in the document a little farther. I need to do this one right here. So this one right here, they're asking me to find side A and this angle. So what I know is I have 10 meters and 38 degrees, so I'm going to say that the tangent of 38 degrees is equal to the side opposite, which is A, over 10 meters. So I'm going to multiply the tangent of 38 by 10 meters. So punch in my calculator tan 38 times 10, and it gives me 7.8 for A meters. And then I want to know theta, so I'm going to say the tangent of theta is equal to 7.8 meters over 25, because it's opposite over adjacent. So I'm going to divide 7.8 on the calculator by 25, and when I did, I got 0.312. Well, that's the tangent of my angle, so I'm going to go tan -1, 0.312, and when I hit the enter button, it tells me it's a 17.3 degree angle, so that's 17 degrees, because they want it to the nearest degree. Alright. Okay, now I'm on the last page, and I'm going to solve for y, and I have another 3, 4, 5 triangle, because this is 5, 4, this has to be 3. Come on, give me a pencil. 3 meters, and then I'm going to say the tangent of, no, I'm not going to do tangent, I'm going to say the cosine of theta. Doesn't matter, I could do either one, is equal to the side adjacent over the hypotenuse, and when I do that, I think I'm going to get that 36.9 again, which would be 37 degrees if they want it to the nearest degree. So let me check and make sure I'm not lying to you. Cosine of theta, let me check. So 4 divided by 5. Yep, 36.9 degrees or 37 degrees. Okay, so if you look at this triangle, I have 7 inches here and 25 here, so I'm going to say 25 inches squared minus 7 inches squared would equal A squared. And when I did that, I got A to be 24 inches. And then I wanted to find theta, so I said that the sine of theta was 7 over 25. Sine of theta is 7 over 25, and when I did that on the calculator, and that's 7 inches, I'm sorry, you need some units, over 25 inches. When I did that on the calculator, I got theta to be 16.3 degrees. So I'm going to report it to 16 degrees. Again, another 3, 4, 5. This one and this one are identical. Sorry, I don't know why. They're just in centimeters instead of meters, so that's still going to be 3 centimeters. And theta is still going to be 37 degrees. All right.